right. All right. It's probably safe to begin. Thanks for joining. I appreciate you watching and checking out my channel. I know if you've watched any of my previous videos or streams, I know it can be boring. Um, it's a lot to have to find parts, uh, put the footprints and the schematic symbols in your library file, your library in KiCad or whatever EDA software you use, to add them to an inventory tracker software, a system like Odo. But it's necessary work for if you plan on taking a product and pushing it to market. I also know I haven't been covering a lot of the ISO hook-ins. I do plan on catching up to that while we wait on parts to arrive. Like I've said before, we're looking about a week, at most 2 weeks turnaround time before we get the components and the PCBs with the stencil. So we'll have plenty of time to catch up on the QMS paperwork and maybe some project management stuff. Um, I'm just as eager to get this project done and ready to rock and roll as you are. That's one reason I'm just kind of barreling through a lot of the design to at least get to the point where we can order materials and have that coming in. So we left off with getting a lot of the UART bridge chip, the USB UART bridge chip, kind of plugged in. I am looking at some reference designs from previous products, projects I've worked on, just to make it a little bit faster so I'm not wasting time in data sheets. Now we're going to go and throw in the auto program routine, find the USB-C connector. I've decided for my products, for anything I design moving forward, I'll be just using USB-C because that's the predominant connector that's on the market now. It's a little bit more expensive. You can still get the B micros relatively cheaper, but there's no reason to. USB-C is becoming the dominant one on the market, and there's just no reason to not use it. Eventually, the connectors will drop more reasonably in price. They're not that expensive now. It's just when you do a price comparison, they're just slightly a little bit higher. So, since we're going to throw in the auto program, I think we'll just kind of design it here. I saved a little bit of time. So I'm going to be switching back and forth to the reference. So the circuit that I'm going to be laying out is pretty much identical to the one Espressif throws on their dev kits for handling the auto program. It's essentially going to be a dual BJT NPN transistor setup. It's basically just two NPN transistors in one package into a nice little SC70-6. That's actually a standard package. And then two resistors is just tied together just right. So when it gets the handshake signals and the modem control signals from the programming software, such as the IDF, to the serial port, to the USB bridge chip, it'll shoot them out on the DTR and RTS signals, which will tell the microcontroller to reboot into bootloader mode so it can be programmed. We'll also grab some buttons to do manual loading in case the auto programming fails. Sometimes it does. Sometimes you have to fidget with these ESP32s and force them into bootloader mode. It's really weird. I've had some weird things, so it's always nice to have a fail-safe with some push buttons. But first, let's go ahead and get this going. I know a lot, again, it's lather, rinse, repeat. If you've been catching up with watching my videos, but it's unfortunate that this is the way it goes. So we're going to download the footprint and the KiCad schematic file. What was that? I finally went through and deleted all the extra zip files. So hopefully that will make it a little bit easier to find what we're looking for. So KiCad, hopefully that actually has things in it. Yes, it does. So we're going to go ahead and go with a footprint. Again, a lot of lather, rinse, repeat. And that's kind of what this video series is wanting to I want to kind of focus on, is to kind of show the reality of it. Now, transistors are typically designated as Q, so we'll just go ahead and stick with that. Again, this is a standard package size, so the SC is 70-6. Basically, SC-70 is the size. -6 means it's got 6 legs. You'll see that a lot. Components, okay. Now we're gonna go pull in the 3D body. All right. Look at that. Yep, pin 1, pin 1. Perfect. All right, save that. Now we're going to go to the symbol and import the symbol into components. For one thing, we don't have this particular symbol. What am I doing? Get distracted by talking. It's another reason I don't like to talk a ton while I'm working on stuff, because I get distracted so easily. So we're going to rename that. Just add Q to the first letter to it. Save it. We'll go through and look at that here in a minute. Some properties. Clean this up. Well, we'll rename those. Don't get rid of that. Description. Get rid of that. Give it the correct footprint. SC70-6. Value. Designators Q. Let's see here. Let's go. Dual NPN. Let's see here. Okay. Let's see. Maximum collector current 100 milliamps. That is critical. Let's see here. Collector emitter voltage 45 volts. Milliamps. Oh, wrong button. All right. That's fine. A negative 55 to 150. See, and it's Rohan's. So we're gonna go. Yeah. One. Part number. Enter. Enter 1A. And for consistency's sake, a value field that we're just going to leave blank. So it's cost low volume 14 cents and 1,000.042. 14 and 042. All right. And as I said before, add it to Odo. That way it's already done. Do we have transistors? Yes, we do. You know what? Let's go ahead and just throw the package in there. It doesn't hurt anything. A little extra information never hurts in the long run. Oh, hey, Mauser. Again, this will all tie in down the road once we create our bombs. And the reason we're using this system is if you plan on running your own business or building products, whatever you want to do, you definitely want to track your inventory. It just makes life so much easier when you want to try to plan what you need to order, what you need to, how you need to build, what you're, so you can keep track of what you're selling. It's just real easy. It's just really a necessity right now. Okay. All right. So we're there. We're there. All right. We're going to okay that. All right. Gosh. All right. You get on my way. Hey. Hey. All right. Okay. So that is kind of messed up. So we have our bases, our emitters, our collectors. And let's make sure that that actually matches the data sheet. That pinout matches. Okay. Base of 1 is 5. And then 2. 5 and 2. Okay. Okay. Collector 3 and 6. That's why they're like that. All right. All right, and emitter 4 and 1. Okay. As far as throwing this in the schematic, since it's not the traditional transistor NPN transistor symbol, that's what I've noticed change over all these years. I might just go ahead and just say that is, when I got into electronics, we had these fancy, uh, squiggles for the resistor, the typical sawtooth shape for a resistor. The transistor had a unique shape. Capacitors had unique shapes. And then over the year, even MOSFETs and other devices had unique shapes. And just over the years, it's just like they're just changing to blocks with what they are. As far as throwing this in the circuit, it shouldn't be too difficult leaving this alone. If it becomes a weird wired jumbled mess, maybe somewhere along the way we'll try to figure it out. But for now, we'll leave it alone. We'll see how it fits. So let's grab that guy. Don't need that. Get out of my way. All right. So you down here. And now we need two 10K resistors. Do we have 10Ks in here? Ah, look at that. Don't even have to waste time adding them. Okay. So, again, you could pull this diagram, pull the schematic for this off of one of the data sheets for the ESP32 dev kit, because this is exactly the same circuit that they use. And I think this is the actual same NPN dual transistor they use. So we have, well, we're going to try to do this as best as we can, considering we have different symbols for this. So it might look kind of messy. So off of the emitter 1, and then emitter 2, let's go get these laid out. Now we're going to net label. One is going to be RTS, and that is off of emitter 1. And then off of the other one is DTR, data terminal ready. No, just want to drag it. Make it look a little different. All right. So RTS. I'm going to move this down here. This guy under it. So off the RTS, we come into the 10K ohm resistor. And then the other side of the 10K resistor, that is off of emitter 1. So that goes to base number 2. All right. Now DTR comes off of the 1 resistor, and it goes DTR to base number 1. Told you this is going to be an interesting mess of wiring. Now collector 1 just goes out, and then collector 2 goes out. Okay, so those go to ports because they go to the ESP32. All right. And then is it ESPEN? And then boot mode. All right. So boot mode goes to collector of transistor B. Basically, collector of transistor 2. So annoying. And then enable goes down here. Hello, stop. There we go. Oh. That's fine. Doesn't have to be perfect looking. Stop. Man, so annoying. Do want to clean this up a little bit. Okay. Easy peasy. So, let's see here. Is there a note field? Text box. All right. So what we're going to do is we're going to throw in DTR, TS. All right. This is just a logic table based off of what you're getting out of the handshake signals off of the computer. Basically, what the idea of software when it goes to flash, what it'll do, what the commands it'll send to the USB UART bridge. And again, this chart, this diagram, will be on the ESP32 datasheet. It's always helpful to throw this kind of stuff into a schematic for troubleshooting. All right, kind of shrink you a little bit. I'll put you down here. Bam. All right. So just like a chart, just to understand what's going on based off of what signals you're going to be getting from the ESP or the UART bridge chip to the ESP32 through the transistors. All right, so that should be set up there. Easy peasy. We're done with that. So we're going to go to, we need to find the USB connector. Let's see here, USB connector. You know what, let me see. Let me look at my reference diagram to save us some time to see if I've already got one selected. If I do, I'll just go and grab the part number. Yes. All right. Here's what we're going to do. USB 4105 GF-A. Okay. Is that the one? Yep. All right. No model, no footprint. Let's see if we can find one here. Ultra Librarian. Snap Magic has everything we need. KiCad step. We're going to download it. All right. Now, one of these will have a zip file or the just a step file. And the other one will have all of them, which is kind of interesting. Yep, right there. Okay. Again, that's going to be a connector. All right, let's grab this guy. Make sure we have that. Go back into KiCad. File. Import footprint. All right, where is that? Again, we're going to save that to CN. Technically, it's a connector. Dun, 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 dun. Everything looks good. We're going to save that. It's got the part number, which is fine. Connectors. All right. Now we're going to properties, 3D models. Now, what I'm hoping is that these get embedded. All right, here we go. Let's see here. Oh, maybe that's all. We have to just rotate at 90. Nope, no little offset. Okay, all right. Beautiful. Save that. And connectors. File. We're going to import symbol. All right. We're going to put the K prefix before it. Save it. Helps me. Yep. 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 Jeez. Hey, shit. Description. Manufacturing. Me and my spelling. Just vowel. Just for consistency. All right. 78 and 44. Okay. As we see. You know what? Let's go ahead. Type C. Type C. Let's see here. Let's C 2.0. Let's just go ahead and type C 2.0. Angle. They call them shell stakes. That's what they're called. That's all right. Shell stakes, mainly to indicate there is a through hole component to it. All right, let's get. Is there anything else? 48 volts, 5 amps, which is important. Because if you want to use it for charging the higher power demand devices, you definitely need to know that, and that, you know, your current limitation, your voltage limitation. Okay, top mount right angle. Okay, that's fine. I don't think you need top mount. Actually, let's do top mount because there are some really interesting mounting designs, styles. All right. Negative 40 to 85. All right. Bump, 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 bump. Done. And again, added to Odo. Alright. 78. It's connectors. Purchase. All right. Bam. All right. So now we got that done. Let's get the KiCad. Okay. Save it. Okay. Dun, dun, dun. VBoss, VBoss. Okay. Okay. DP. So typically, DP2. Most of the time, you will just tie these together. That way you get the full proper connection of a USB cable, DP, D2, or the positive and the negative differential. Let's see those guys. CC1. Just kind of cleaning this up a little bit. Just to make it a little bit more logical. CC1. No. Shell grounds. Okay, those are the mounting stakes. Those are your two internal grounds. VBus, VBus 1. That's fine. We'll leave that alone. We'll save it. So, go back to our schematic. And we're going to add that. USB. All right. So, grab. All right. All right, now move this over here a little bit. We'll clean that up more later. Let's get this guy over here. Get our grounds in here. All right. So we're not going to care about these guys. We don't need them for this part, for this project. All right. Let's get these guys plumbed together. Well, all right. Okay. Now, since we're on the same sheet, we don't need the ports over here. So what we're going to do, underscore DP. you guys out of here. Positive. Negative. All right. So your data positive, your data negative. Now, something I do want to throw in here is our TVS diodes. Okay. Never hurts to have them. So we're going to no connect this one for now. And we're going to pull this guy out. Pull this guy out. All right. All right. Bam. All right. So let's throw some TVS protection onto the USB ports, the USB inputs, and the V-bus, because this is a point of contact, easy for a human, and it'll just help reduce the chance of damaging the bridge chip. So now we have a decision on what we might want to do from here. So I know I want to throw in manual. We want to throw in manual buttons for the boot and enable pins. So we actually have enough work over here, enough room to throw in two switches, two buttons. So let me find the two relays. I think I've got manual buttons I threw on the original design that I'm referencing. Yes, a button that I like using. SW435 151014845. Oh, wait a minute. Okay. That's my internal part number. That's the number I want right there. All right. Beautiful. So these are like nice little momentary tactile switches. They're kind of small, but that makes them nice for a lot of designs because they'll drop in. They're not extremely expensive. They're nice SMT, real easy to use. So we're just going to go ahead and nab these guys. All right. All right. Let's go and download. Extract. I just hope they have the KiCad in here. 435. We've been lucky so far. We don't have to create any footprints from scratch. So, in our typical fashion, we got to go to File, Footprint. Yeah, we'll leave that. Now we'll name it. We'll just leave it the name because it's for this switch. File properties. Delete that. We're gonna find the. Oh, that is just beautiful. Beautiful. All right. Now to the symbol. File, import symbol. And we're going to prefix that with SW for switch. All right, we'll go through and we'll fix these pins in a minute. I'm going to get this part of it done. We'll point that to the right footprint, the components footprint. Okay, okay. And again, for consistency. Bam, 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 bam. So we just gotta get 54 cents and 363. All right. And everybody knows what time it's for. Sales. 54 cents. Now we don't have a switches. We're going to add a new one. Switch under goods. You know what? And I got ahead of myself, but I do that a lot. So. Tactile. Tactile. Normally open, momentary. Don't want to get ahead of myself too much. Did I? Oh yeah, I haven't finished adding that in there. All right, let's see here. Should be 12 volts, 50 milliamps. That's important. It's not 12 volts at milliamp. Let's see here. Go ahead, tactile SPST. Okay, do we have no temperature range? I'm not going to bother digging that up. It is RoHS. All right. Now I can throw that in here and get this guy going here. Boom. Purchase. Save. All right. All right. Okay, that's saved there. Go okay here. Now let's get you out of my way. All right. I don't like the way that's set up here. Get out of my way. I'll open one. I'll open two. Common one. Common two. Ground two. This is just kind of a big. All right. Good, good, good. All right. So we'll go to the schematic. Let's add our newly added switch. All right. So we're going to also pull in a 10K resistor for pull down. RC0603. 10K. All right. All right. All right. Actually, no, we don't need pull down resistors. My bad, because this is really nice. Doesn't really matter what side we throw things on. So I'm just gonna. Oh, stop. There we go. Just because that. All right. And might as well hit port in. Help. Boot mode. Copy and paste that entire circuit. And ESPEN. Boom. So the boot mode, we don't have to worry about a pull-up resistor over here because we've already got it right here. Now, if we really wanted to, we could move this 10K resistor over to here, but it doesn't matter. We could have had these on the circuit, on the schematic with ESP32, but that's fine. It's not going to hurt anything. It doesn't cause any problems. All right. Now, let's look at this and think if we want any sort of test point? And I'm going to say yes. And it shouldn't cause too much of a problem, but one thing I've run into. Where's your test point? Now, because I've run into these problems before, where you're troubleshooting your differential pair, and there's nowhere really to tag on to because the pins for this guy are underneath, and then this is a QFN basically where all no leads, where all the pads are on the bottom. It's really hard to tag into. Also, let's throw in another test point. We're gonna throw that in, down here. Because say we have test points to just to validate our V bus, and then because we don't have to actually populate with these test points, we can as necessary when we go to test if we need to test something. If we find that having the test point there will make it easier to clip scope probes to or whatever, or we can just solder. So off the bat, we'll just leave the test point holes empty. That way there's no component, nothing in the way. So what I think we should do is no harm, no foul, because they're technically just through holes. So let's go ahead and do you here, you here. Let's get two more. Can never have too many test points in some cases. Especially if you have a product you intend. You know what? Let's make this a little bit easier on ourselves. All right. All right. You know what? Let's stop. Come here. RTS. And DTR. Just in case we need to troubleshoot the handshake signals, the modem control signals. Again, you learn from experience when you have to troubleshoot this kind of stuff in the field. All right. And the reason I'm not putting TVS diodes on this stuff is because typically in the field you wouldn't populate these. They wouldn't really be a place where human hands would be touching, would be interacting with. It'd be in an enclosure or something. So I'm not going to worry about that. These are just for testing. A final bill of materials for a release version would have them as do not populate. These are only for internal testing and troubleshooting. They're just through holes, no harm, no foul when you're getting your board your PCBs built. So now we're a little busy on our schematic sheet, but that's fine. I think we are done with this. We're done with the USB to UART bridge interface and all the supporting circuitry, a few extra supporting things. Right here, the switches for program mode. We might throw this switch in for a few other modes, other things. Who knows? We'll see. So one of the things I want to do is, all right. So let's get its name. So we're saved here. All the the no connect flags are set. Go back up to here. Okay. Copy that, and that is stepper driver. Okay. So now we've gotten our stepper driver. Let's copy this. Go to the schematic sheet. Now, I'm going to just kind of start throwing in a few of the PowerPoints. We're going to need ground. We're going to need ground. Power supplies. We're going to copy that. I know we're going to need that. And I think we also have, so we've got a four terminal pluggable. Perfect. Stepper motor is a 4-wire. So we're just going to go ahead and throw that in here. We're going to need it. We're going to use it. Let's just go ahead and throw that in here. We'll just slap it down here. Because we know we're going to need it. We're going to use it. Let's see here. Anything else I know we're going to need for this? Right off the bat. No. Because the stepper circuitry is going to be a little bit more complicated to throw together. I will reference a past design for another project I worked on that has a stepper in it. That way I don't have to fumble around through the data sheet. And there will be a small handful of parts we'll have to add. Obviously, the main driver IC, a bunch of resistors, some nice bulky electrolytic capacitor we'll want to throw in here to feed the beast. We may go ahead and put the fan connector in as well on this schematic sheet. And that should be it for this. So before I go, like I said earlier at the start of the video, I know I haven't been following too much on the QMS. We'll get caught up on that while we wait on parts to arrive. I'll do some streams and YouTube videos dedicated to just those functions. Just get caught up, try to get the documentation all caught up. And then also, I think what I'm planning right now are 3 more sort of video series. I'm not going to stream or anything. They're just going to be straight to YouTube with a release schedule throughout the week. So they're going to be like basically limited short run series. One is going to be for another design of another project, but I'm going to do it in Circuit Studio and not KiCad, uh, and be using my, what I might do different is maybe the first, pardon me there, the first episode, I'll probably cover some initiation, project kickoff, things like that. But the video is not going to focus a lot on any of the QMS stuff or the project management side of that. I'll off camera go through, create a block diagram like this, have it ready to go, show that. Uh, I'll have the predominant parts already selected. Um, I'll be using my existing files, my schematic symbols, and footprints that I already have in Circuit Studio. Uh, so hopefully there won't have to be a lot I have to add. If I have to add anything, I will try to do it off camera and stick to just design and PCB layout to make the videos as short as possible, more digestible, and not drag on. I'm not a very entertaining person, and my goal is to teach and inform. Uh, so maybe like the first video, or I'll show at least entering one or two parts in the Circuit Studio for those who aren't familiar with it. Uh, just so you can get an idea of that process. I'll be using my personal live file for Odo for parts entry and all that. Uh, this isn't a live file for what I do on the side. This is one I just created. That way everything was empty. We're starting from scratch, even though I ended up duplicating a lot of the same parts that are in my main file, but it's okay by me. It doesn't bother me at all. Any video moving forward, if I do any more with KiCad, I'll do it with this setup. That way everything's consistent. And I'll just keep adding to that tutorial. Maybe I'll have to figure all that out because that tutorial video series might be more inclusive than just what we've got. Maybe I'll just throw in the other projects. Who knows? We'll figure that out. I'll have to figure that out as we go. Because then I want to do two other videos that kind of will parallel, but yet kind of be their own thing to the other project I want to work on. The one video series is going to be pretty much just the QMS side of things. We're going to go through and actually get all the QMS stuff for my business kind of written up. I've gotten some stuff going, but we'll kind of get it all drafted up together, show you the process and all the intricacies that you have to deal with. And then another one will be the project management side of it. So those will probably be shorter videos, like 15, 20 minutes, depending on the different subjects to cover. So I plan on starting to record those and maybe start uploading to YouTube in January throughout the week. Maybe, the electronics early in the week, the QMS, then the project management stuff. They'll be limited runs. I don't expect them to drag on forever, but they'll be separate. With this series, I'm just kind of trying to combine everything into one, so viewers really get the feel to how it really works. A lot of I feel like a lot of the YouTubers that do things like this don't show you the boring stuff, the hours it takes to actually make something like this come together. They do bing bang boom, and you've got the schematic, you've got all this, or you've got all this going, and boom, you've got a finished product. But there's so much to it, and it's all important. You don't want to skip out on any of it because at the end of the day, it's your product. You want to make the best possible impression and for your customers, the most reliable product possible. And this is all for the things you need to do to make sure you have it. You want all your ducks in a row before you even list something on Amazon or eBay or Etsy. You want to make sure you have all your ducks in a row. That way you can answer any question that comes up. You already are aware of most of the use cases. You can recommend use cases, and you might even be able to help understand edge cases, gray area cases. So I'll end the video and stream here. I thank you for watching. I really appreciate you checking us out, and I will catch you next time. Have a nice evening.